Thank you, Emer, and thanks to my colleagues in the water programme for the invitation to speak on this interesting and important area this morning. So I was in the water programme in the EPA for many years, and 6 or 7 years ago started asking questions around climate adaptation, and look what happened to me. I got moved, and I'm doing this now. So anyway, we'll have a look at why we're doing this, the point of this, and the main, I think from a sectoral perspective, from water sector's perspective, the salient pieces in relation to this work. So why are we doing it? Most of us are familiar with the risk that we're going to face in terms of flooding. So in terms of water services, you've got, overflows, sewage overflows, etc. From a water quality perspective. This is a far more energetic environment with more frequent and worse flooding. There's more scouring, there's impacts to hydromorphology and water quality. And if we look then at the other end of the hydrograph, we're likely to experience more droughts in future, and that will cascade through from other sectors into the water quality sector and from water services into other sectors as it becomes more difficult to sustainably abstract water and to discharge treated wastewater if we have lower flows in summer months. And the real challenge is that we're likely to experience both of these scenarios at the same time, more flooding and more droughts at the same time, which is a bit counterintuitive. But there'll also be warmer temperatures. So in summer months, we're likely to have smaller volumes of warmer water that lead to issues that we've begun to see in the last couple of autumns, such as increased algal blooms, etc., which would be, we think, a more significant problem going forward. And they've already been mentioned today. And as we move through the next decades, the rise of invasive species due to a more favourable habitat, due to temperature changes, etc., is likely to become an even more significant problem that we're going to have to face. There'll also be hydromorphological issues coupled with that, again, that drought and more intense precipitation piece in relation to mass movements and the impacts hydromorphologically on our waterways from landslides, peat slides, etc. And then there'll be compound and cascading risks. So this is obviously runoff from a field. It's got a high entrainment of nutrient and suspended sediment. There's an impact here. There's a climate impact on food production. There's a climate impact on water quality, biodiversity, and transport links if you look at the road at the bottom. And the reason I've included this picture is just to call out the piece around maladaptation. If that road infrastructure is strengthened to transmit that increased runoff off it more quickly, we have to make sure that we're incorporating adaptation measures so that that water doesn't end up in the receiving environment in the water body violently fast and with that entrained sediment. So we have to use those nature-based solutions to make sure that we're addressing these kind of cascading risks across sectors. We have to think wider as well in relation to our risk assessment and adaptation. We saw in the presentation from the EEA earlier this morning about significantly hotter summer temperatures in southern Europe and lack of water resources. That is quite likely to manifest itself as increased migration and increased tourism here in the summer months and year-round in terms of migration. But in many areas, this will manifest itself as putting significant pressure on the water environment and water resources in places where there's currently, it's on a knife edge in terms of supply or in terms of the environment to assimilate the treated wastewater. So that's something that we have to look at in scenarios around risk assessment towards the middle of the century. And finally then, when we're looking at climate risk, we're bound under policy and under the structures that we're using to look at the societal vulnerability and socio-economic vulnerability. We have to take account of individuals. We have to take account in our long-term planning of changing population. We're likely to have significant increased population in the country. Changes in age profile as well have to be taken into account, and the trickle-down impacts, for example, on water services in terms of social cohesion, etc., we have to consider as well as we assess the risk on climate. So you can see there's a web of interlinked, cascading, transboundary risks that we have to take account of here that we probably haven't addressed appropriately to date. So just in terms of getting our terminology very clear, because we're familiar, this isn't a room of adaptation experts, so to speak, and adaptation and resilience are probably used interchangeably sometimes. Risk assessment is the first stage in the adaptation process. It's around identifying the climate risks that we're going to have to address. Adaptation is the process by which we will solve them, and the outcome is resilience. So the analogy in the water sector is that integrated catchment management is the management process. Healthy ecosystems, healthy water bodies, high and good status water bodies are the outcome. So resilience is the outcome of adaptation in all cases. When we look at risk in relation to climate risk, it's slightly different than, I suppose, risk assessment that we would be used to in water or in infrastructure historically. We're looking at hazards, which we're used to doing in terms of the climate hazard, be it drought or increased precipitation. The exposure is obviously where you have a receptor there. So if you have a storm on an offshore island, it's not the same as that same storm hitting Cork or hitting the Liffey catchment in Dublin. But vulnerability is this third piece under the IPCC risk framework, the Intergovernmental Panel on Climate Change, that we have to take account of. The relative likelihood that an individual will be impacted by climate impacts differs by individual based on their age, their socioeconomic status, their illness or their additional needs, and we are bound to take that into account when we assess risk of climate impacts in populations. So it's an additional perspective that we probably haven't looked at in many cases heretofore. In terms of how we're approaching risk assessment, both in Europe and nationally, there's kind of a nested or stepped approach. The European Climate Risk Assessment was published earlier this year, and the objective of the European Climate Risk Assessment was to identify priority policy areas for the EU that need to be addressed to safely manage climate risks. That uses a systems and an elements at risk system and a sectoral system that we have brought into our national climate risk assessment. This piece of work hasn't been done before. It's due to be completed in early 2025. We published the method report last week, which can be accessed via that QR code on the screen there. And this is a very important step because up until now we've addressed climate risk assessment and adaptation on a sectoral basis. We're still doing that, but now we have this national risk assessment sitting on top of that, which will essentially provide us with a national risk register of climate impacts that are prioritised based on the urgency for action that's required to deal with them. The sectoral adaptation plans sitting under that will then contain more detailed sectoral risk assessments, and they will be aligned with the NCCRA, that's the National Climate Change Risk Assessment. They will be aligned to that methodology through guidance that's due to come out in the next couple of months so that the approach will be logically consistent between them all. And then you have local authority climate action plans. They're in place. They have very, very robust guidance in place as well, semi-quantitative risk assessment guidance, and that will be updated appropriately over time as well. So the approach that we're taking for the National Climate Change Risk Assessment is a semi-quantitative approach. The qualitative approach was what we did for the sectoral risk assessments or the sectoral adaptation plans in 2018. That's essentially a thought exercise. What are the likely risks of warmer, wetter winters and hotter, drier summers? What types of impacts would we likely see, such as the impact I showed at the top of the presentation? There was no attempt spatially to map them in most plans, with flood risk probably being the exception because it was driven by the CFRAMS process. But what we want to move to is a semi-quantitative approach. Now, at the other end of the scale, you have a fully quantitative approach, which is a fully numerical approach. That's really for project level or at least sub-sectoral levels. It's too detailed for a national level assessment. But we're going to use a semi-quantitative approach. So we use nationally consistent data. We use it in a consistent way using standardized risk assessment criteria so that we can prioritize risks across sectors. So what is the relative importance of addressing risks in the energy sector, the water quality sector, the water services sector, the health sector, etc. It gives us that strategic overview piece. And this is similar to other countries that are progressing this process, such as New Zealand, Australia, the UK. The UK is on its fourth climate change risk assessment. And I should stress this is an iterative process. Each risk assessment provides as many questions as it does answers, and it grows through time. And as well, that method document that I mentioned previously, that's a working document. When we finalise the process next year, that will exist in its final form, but it's online in draft form currently. So that semi-quantitative piece, we're using expert judgment to fill gaps, but we're using quantitative data where we have it to try and make this a more robust assessment. What data do we use? Because obviously I won't go into this in detail. This is the cascade of uncertainty. There are many climate models, there are many river flow models, there are many socioeconomic models. What will the population be in 30 years' time, etc. And we have to make choices around those and constrain them in a robust fashion. Now, the presentation that Conor is going to give next shows some of the very, very detailed and technical science that underpins the development of National Climate Services and river flow projections, and that's very much taken into account in deciding what standardised data sets that we will choose. So for the first time, in comparison to 2018, we now have a standard set of national climate projections that have been worked up by Met Éireann. That's the Translate set of national climate projections. And they sit as, I suppose, the foundational element in what's called the National Framework for Climate Services. So this is a framework for the provision of standardised, interoperable national climate data. And it's been coordinated by Met Éireann, by the Climate Services team in Met Éireann, and it's its purpose is to make sure that we have appropriate information to allow us to identify the risks and to plan for adaptation in Ireland. So Met Éireann are leading out on the climate projection piece of it, and they're working with other data providers such as the OPW for flood risk data, the GSI for groundwater future projections, and the EPA for future river flow projections, and they'll be produced or indexed to the Translate data set so that these will all sit coherently as a suite of national climate data. We also need to identify what projections for demographic, socioeconomic, land use and energy infrastructure we're going to use in the risk assessment. So we don't have very much to do. It's quite simple. So just in terms of, I suppose, a snapshot of what are we choosing, what are we selecting to follow here. The risk framework I've mentioned is the IPCC risk framework. We are aligning to that and to the ISO 14090, which is the Climate Change Risk Assessment ISO. We're choosing to use RCP 4.5 and 8.5. RCP is representative concentration pathway. I suppose it provides a snapshot of what the future will look like under a certain emissions trajectory. Our policy goal is to reach net zero by 2050. The track we're on and the track the world is on is probably closer to RCP 4.5. So from a risk assessment and an adaptation planning perspective, it doesn't contradict the national mitigation objective, but it is very, very important to plan our infrastructure and our adaptation plans so that we can achieve resilience for the path we're on as opposed to the path that we're trying to get onto. The timeframes that we've selected are 2030, 2050 and 2100 for assessment. The climate data, as I've said, is the Translate data set, and hydrological data for the risk assessment I previously mentioned, OPW, GSI and EPA. We also have to take account of sea level rise. We're going to use OPW and UK CP18 data for that. In terms of population rise, we're likely to see population rising significantly towards the middle of the century, and the ESRI have just completed an update on our population projections because we've exceeded the population projections that were used for our 2040 planning framework. So we're trying to incorporate that data. It has its difficulties. We have projections of what the overall population will be. We need to decide, for the sake of our risk assessment, where those people are likely to live. Will we continue to see the highest population growth in Dublin, for example? And the population will be older as well. So where are vulnerable people going to live in 2050, and what proportion of the population will be vulnerable? Decisions have to be made on that. They are risk assessment decisions. They are not predictions. We have to be very clear about that. That vulnerability piece, as I said, being key under just transition and just resilience, etc. So how this fits in then, we've come a long way since 2018 where you could use any data you wanted, you could use any criteria you wanted in terms of your risk assessment. If we look at the bottom left of this picture, we have the National Framework for Climate Services. That's coordinated by Met Éireann. So that means for the water sector, for example, all stakeholders can now use standardised information, standardised climate projections, standardised river flow projections, etc. So there's an equity piece in this. From the smallest stakeholder, public or private, to the largest stakeholder, you now have access to very accessible, high quality information. And that feeds into the Climate Ireland space that the EPA coordinate. Climate Ireland is Ireland's adaptation platform. It's the home for a single, I suppose, one-stop shop, you could say, for adaptation planning, guidance documents, risk assessment guidance. We coordinate the setting of national risk assessment criteria, and it's the dissemination point for a National Framework for Climate Services data that's relevant for adaptation planning. So in the bottom left of the screen, you have standardised data, standardised information. In the bottom left of the screen, you have standardised, bottom right of the screen, you have standardised information. Bottom left of the screen, you have standardised use criteria. And that feeds into improved, standardised adaptation planning at a sectoral, local authority and individual stakeholder level. So when we have this high quality information and standardised use criteria, our national climate change risk assessment technical approach is in 3 stages. The first stage, which we're currently in, is the risk identification stage, the object of which is to produce a long list of climate risks and cascading risks, transboundary risks, etc. That will be complete, I think, in the next month and a half, and we will then move into the kind of semi-quantitative risk assessment stage, where we will try and constrain that using spatial data where we have it and quantitative data where we have it. And that will produce a shortened list of risks. And what we'll have at the end of that is a shorter list of risks of gross climate change risk on those sectors. Stage 3 then is where we will take that shortened, semi-quantitatively informed list and we will assess it in terms of adaptation measures that are either in place or planned, and also the urgency for action based on urgency criteria in terms of needing to address outstanding issues. So that will leave us then with a prioritised list of climate risks with an urgency rating for action in each case that will inform, I suppose, the climate action plan and trickle down into the sectors. And there will be, as I said, associated guidance for the sectors to ensure that their risk assessments at a sub-sectoral level align with the approach that we've taken. Just to show you, I've talked about cascading risk, and I don't want to get into this in great detail. This is from the European Climate Change Risk Assessment, but it shows how you begin to map out these impact chains and cascading risks. So if we look at droughts in the top left, that's your climate hazard, your exposures and your vulnerabilities are there in the middle, decreased availability of water, failure of e-flows, water scarcity, etc. And that they feed into your risks down the bottom. So at the bottom left, you have risk to aquatic and wetland ecosystems. That cascades into your biodiversity sector. Just to the right of that, you have risk to crop production. That cascades into food security, and so forth. So it's to map those intersectoral cascading risks and transboundary risks, I should add, from externally insofar as they can be. There's also a piece around tipping points. It's more establishing a logic for how we keep an eye on tipping points. We can't manage them yet on a national basis, but it's just to make sure that we're taking a holistic look at this. But that's just a flavour to show you how we're working through this process in all 14 identified adaptation sectors and beyond. We're incorporating the wider EU adaptation sectors as well in the assessment so that we're being as holistic as we can. That will feed into adaptation planning for the water sector, for example. The sectoral adaptation plans, it's important that the goal is very, very clear. The object is resilience. What timeline are you being resilient to and what projections? So there's a number of ways you could do that, and decisions have to be made in a sector as to how to do that. You could be resilient to a 2 degree rise in temperature, irrespective of when it occurred, or you could be resilient for the impact you'd expect to see under RCP 4.5 by 2050. So there are two ways of looking at the same thing, essentially. We are suggesting that now that the NCCRA is in place and you will have high quality risk assessment data aligning to RCP 4.5 with the 2050 timeline, that's a very, very good starting point as a resilience target. How will decisions be made under uncertainty? Something that we hear repeatedly from people trying to grapple with this is that they want more certainty in data, they want more granular data. I have to make it very clear that the data we have now is as good as we will ever have. There will always be uncertainty in this, and we have to be more comfortable about using the uncertainty and the statistical robustness around that to make decisions, as opposed to saying we can't do anything until we have certainty, because we never will. So it's important that we get a very clear methodology around taking decisions under conditions of uncertainty. It's analogous to developing a mine in some ways. You have a conceptual model and you update it as time goes on. And then what indicators? How are we measuring progress? And in the next few weeks, there'll be an EPA TII report out on a pilot scheme to develop adaptation indicators, and I would recommend that everyone reads it because there's generalised lessons in there for other sectors in developing their indicators. In terms of adaptation regulation, this is the doing of it. This is a very important step in the process, and recently the EPA incorporated the requirement for an adaptation plan into a licence for the first time. This was the Uisce Éireann treatment plant in Ringsend, and it requires the licensee to prepare an adaptation plan taking into account the impacts of severe weather and under the latest flow projections and agreed standardised future climate projections, aka the National Framework for Climate Services, and an action plan with a timeline for implementation for improvements and adaptations that need to be made to minimise the impact of severe weather. That's your resilience piece. So this isn't the achievement of resilience. This is a very, very important step in the process, and it represents progress. The actions built on the ground is what will achieve resilience. So we get to that point. Final thoughts I'll leave you with. Adaptation is an integral part of long-term planning. Everyone is going to have to wear an adaptation hat from now on. It's analogous to health and safety 20, 25 years ago. It was an imposition. People saw it as an other. They eventually, it gets taken on board, it gets assimilated into your professional practice, and everybody now looks at their work through a health and safety lens. Everyone involved in long-term planning or operations is going to wear an adaptation hat and should embrace it. Differently to historical approaches to risk assessment, vulnerability, equity and justice are key components in resilience, risk assessment and resilience planning, and have to be taken account of. A quantitative adaptation target, as I said, it's very important to underpin this, and we would suggest aligning to the approach that's in the NCCRA risk assessment guidance as the plan objective. Observation networks are key to identifying changes as they occur. So the impacts of climate change, we can be quite confident, will not be the same across the country. It's very important that we have our temperature, our meteorological and our hydrometric monitoring networks that are regionally representative and operating to a high standard so that we can accurately identify the changes as they occur and base our regulation and our management on measurements as opposed to models. Next, climate change will make many environmental issues, such as the pressures on water bodies, it is likely to make them worse. And magical thinking needs to be called out. You know, it's 24 years since the Water Framework Directive came into being. It's the same distance forward to 2050. It's not in the distant future. It's those of you here who may be in college will be mid-career by the time we get to 2050. It's not that far away. 2015 seemed like a long time into the future. You know, in the early noughties, 2027 seemed like a long time away a few years ago. Now it's 2.5 years away. So we're getting there very quickly. The achievement of environmental objectives under river basin management planning, integrated catchment management, that is how you will achieve this. Water bodies that are not at good quality now will not be at good quality in a climate-altered future. So the achievement of environmental objectives is the strongest adaptation tool we have in our toolbox. Healthy ecosystems are resilient ecosystems, and it will be achievement of our existing objectives that make us resilient, and not some unidentified plan that we don't have. And finally, just to finish on a positive note, you know, we're leading on data development. We're coming from a situation where 6 years ago we had really, really good science and academia. We had no structured approach to that nationally. So now we have risk assessment criteria, standard data provision, and we have it coming into regulation as I've shown in the recent license. So we're making progress on this, and we just have to keep up the momentum. So I'd just finally say, if I could, you're all going to be working in the adaptation space. I'd invite you to email climateireland@epa.ie and sign up to the Climate Ireland Adaptation Network. That will provide relevant news, information, updates, and an annual seminar on adaptation for those grappling with this. So I hope that was interesting, and thank you very much.